Okay, here in 5.2, we're going to be taking a look at solving quadratics by graphing. You know, what we just finished up with in 5.1 is just graphing quadratics. So that's going to be a big objective for us is number one, graphing quadratic equations. Number two, finding the x-intercepts of the graphed quadratic. We'll talk about what those mean. And associate the x-intercept with the solution. In other words, the root, the zero of the quadratic equation. So take a look at number one, reviewing graphing of quadratics. Okay, so these are things that we did in 5.1 just to make sure that we can recall the components of graphing just a basic quadratic. So the first question is, how can you tell if an equation is a quadratic? Okay, hopefully what you answered was there's an x squared. That x squared indicates that we have a quadratic term, and hopefully that we're going to be graphing a quadratic. Now remember, some of the basic components of a quadratic, like the shape. The shape is a parabola. And a parabola is either a U-shaped or an N type of shaped or some type of arch. Okay, and so that's the parabola, so we know. Now what indicates, let's say, the direction the shape is facing? In other words, the concavity. Well, it's going to be the A value. If A is positive, it's going to be concaved up. Think smiley face. Okay, and if A is negative, then what we have is a frown face, or it's going to be concave down. So keep that in mind as well. The y-intercept's really easy. That is the C value of the quadratic. Okay, so once we identify the A, B, and C, the C value would be your y-intercept. The vertex is very important when we talk max and mins. It's not going to be as important here in 5.2. We still need to be able to find it in order to help us graph. Remember the vertex, the x value is the opposite of b over 2a. And then the y value is 4ac minus b squared over 4a. You can also take the x value of the vertex, plug it back into the function to find the y value if you prefer. Axis of symmetry, remember that's a fold line. It's x equals the same x value as the vertex, so the opposite of b over 2a. So an example over here, what we've done in 5.1, if we graph this quadratic function, what we need to do is find the vertex, which is the opposite of b, so 4. All over 2 times 1 is 2. So our vertex is going to be 2 comma something. Okay, and so we go over, and then that's going to be our axis of symmetry as well. Now, to find out what our y value is, I can plug it back in. 4 minus 8 is negative 4, minus 5 is negative 9. So this one's going to be a little bit off the charts here. But we have 2, and then we have negative 9 way down here. Let's just assume it's right there. Okay, now what we want to do is we're going to go ahead and we can plug a few more points in, or maybe your y-intercept's negative 5. And so what you have is you can plot those points. Maybe plug in, let's say like 5. So we have 25 minus, so it's a t-chart. Okay, so if you plug in 5, you get 25 minus 20. 25 minus 20 is 5, minus 5 is 0. That worked out really nice. Okay, and here's my axis of symmetry. Right there, goes through the vertex. And then I can fold this over. 1, 2, 3. So I go 1, 2, 3. And there's another one. So I've got my parabola established. And there's our quadratic function. That's what we did in 5.1. Carry that same information over to 5.2 because we're going to be doing the exact same thing. The difference is instead of emphasizing maybe, let's say, the vertex, we're going to be trying to emphasizing these x-intercepts. So if we go ahead and take a look, the difference between a quadratic equation and a quadratic function, you can see here a quadratic function is in functional notation, f of x. Remember, that's the same thing as y. F of x is the same thing as y. That's called a quadratic function. That's what we graph. What we're solving for is what they call a quadratic equation. So notice that what we've done is we've replaced the y with 0. So f of x is the same thing as y. And the difference is f of x became 0. So do association here. If f of x and y are the same thing and f of x became 0, then wouldn't y value be 0 here? The y value is 0. And they want to know what is the x value. Remember back in early Algebra 2 and maybe even Algebra 1 when we did x and y intercepts, how do we find the x-intercept? We would plug in 0 for y and solve. Any time that you're solving a quadratic. Okay? And actually it holds true for higher degree polynomials. Anytime you solve a quadratic, you always want to set the quadratic equal to 0 to solve. Now when we talk about solutions to quadratics, there's a lot of names here that we need to be familiar with. One of the names is called the x-intercept. That's what we're looking for. So on a Cartesian coordinate plane, what we're looking for is where that parabola crosses or touches the x-axis. That is the x-axis. And those are the x-intercepts. Those are also considered the solutions. Other names for it are zeros and roots. So these are some vocabs that we need to be familiar with. They all are the same thing. They all mean solution. They all mean x-intercept. They all mean root. They all mean x-intercepts. And so as we're going through this and they ask you to solve a quadratic, really what they're asking for is what are the x-intercepts? If they say what are the roots to this, they're asking for the x-intercepts. Those are synonyms of each other. Make sure that we're familiar with those vocab words because we'll be using all of those in just our daily lectures. Okay? Now identifying the solutions to a quadratic graph. Okay? So we're going to do it by graphing. First, what you want to do is graph the quadratic functions. Again, use all the tools that we did in 5.1. You were very good in 5.1 at utilizing the axis of symmetry, the vertex, the y-intercept, a t-chart, and you need to establish this graph, the parabola. Once you have established the parabola, it becomes a little bit easier because all then you have to do is locate any of the values that touch the x-axis, if there's any. So a problem like this one, notice there's two solutions. How do I know? It's because it touches the x-axis twice. Right there and right there. So notice I haven't talked about the vertex. The vertex allows us to find max or mins, and it helps us to graph. It has nothing to do with our solutions. Our solutions are the x-intercepts. Where does it cross the x-axis? These x values are the solutions, the roots, the zeros, the x-intercepts. Those are our values. So like on this first problem, the answers are 1 and -2. 1 and then -2. And if I plugged 1 and -2 in whatever this quadratic function is, my result would be a 0. Because that is what the solutions of a quadratic are what x's make the y 0. Okay? Taking a look at the second one, you could get one solution. These are the only three possibilities you can get. 2 solutions, 1 solution, or no real solution. Now what's that imply? Hopefully what you're thinking is, well, it implies that there should be an imaginary solution. Yeah, there's going to be complex solutions on this. Remember, if we're dealing with functions, we're dealing with more real-life scenarios. We're not going to have as many imaginary or complex solutions. Usually we'll put no real solution. So we'll talk about that when we get to them. But here what we have is one solution. Notice the vertex is the solution. But that's not always the case. Just like over here, what we have is this is a solution, and that's a solution as well of -2 and of +1. So this one right here, the answer is x equals 0. Now notice I'm not putting the y value. I'm only putting the x value. Remember, the y value for all of these are going to be 0. This is the point -2, 0. This is the point 1, 0. This is the point 0, 0. Anytime it crosses the x-axis, our y value should be 0. That's what we're trying to do, is figure out what x makes our y 0. And so this one, notice it doesn't cross the x-axis at all. Therefore, there's no real solution to one like this. We would have to end up using it some other algebraic way to find the solutions. But for right now, what you would put is no real solution. Okay, let's take a look at some problems. And what I want you to do here is I want you to pause the video as soon as I'm done talking here. And I want you to figure out what the solutions are to all of these. Then replay the video and see if your solutions match up with mine. Okay? So go ahead and pause right now and then come back to it real soon. Okay, now here are the solutions to each one of these. This one right here, the solutions are 1 and 2. We have 2 solutions. Now we may not know what they are, but there's 2 solutions. This one, how many solutions are there? There are no real solutions. Okay? This one right here, there is 1 solution. I don't know what it is. It's positive, but it's 1 solution. So these first 3, we don't know exactly what the answers are, but we know how many. Okay, and that's a good start. The rest of them, we should be able to find exact answers. So let's look at this one right below it. Notice that it crosses right there and right there. What are those values? Looks like x equals -1 and x equals 3. Those would be considered the solutions to this quadratic equation. Okay, so we graph the function, we solve the equation. What's the difference? The function is like this, and we have x's and y's. The equation is 0 for f of x. That's the difference. Okay. Let's go ahead and solve the rest of these really quick. The solution to this one, notice it's just one solution, x equals 1. This one down here, no real solution is what we have. It doesn't cross the x-axis at all. Take a look over here, 3 and 4. X equals 3 and x equals 4 are my 2 solutions. 2 and 6, x equals 2, x equals 6. This one right here, now this one's interesting. I want to put this one up here to show you. I won't give you many of these, and if I do, it's mainly just to show you that the solutions are in between integers. So here, notice it's not -1. It's somewhere in between -1 and 0. So our solution here is in between -1 and 0. The solution here is in between 2 and 3. I don't know exactly what it is. And the reason I show you this is because I want to make sure you understand graphically we have potential problems for errors. Where we could graph it perfectly, but it crosses somewhere in between integers, makes it very complicated to find that value by just eyeballing it. So we have to have other methods. That's where we're going to learn in 5.3 and 5.4 and 5.5, all these other methods of doing it algebraically. And so that's to come. Right now, we won't get many that look like this. I just wanted to show you one. The rest of them are all going to come out perfect and pretty ponies like all these others. Okay? Take a look at 3 examples. Let's graph these, okay, and state the solutions. Okay? So first off, notice this is a quadratic equation because it's set equal to 0. We need to graph the quadratic function. The quadratic function is really the same thing, but it's going to be in functional notation. This is the function. The one up here is the equation. So we're going to graph the thing I have underlined there, and we're going to solve the thing I have boxed. So we're going to graph this right here. So we go ahead and let's say we find the y-intercept, which is 0. My c value is 0. Okay? Then we find the vertex, which is the opposite of b over 2 times a. So we end up getting 3. I plug 3 back in, I get 9 minus 18, which is negative 9. Again, if I'm going too fast, pause, go back, make sure you see where I get these values. So I go 3, negative 9. Okay? Once again, I'm off the charts. That was really smart. Okay, so 7, 8, 9. So we're way down here. But again, the vertex is not that important to me. It's really where it crosses the x-axis. And so we're just using the vertex to help us graph. That's all we're doing. So there's my axis of symmetry. I fold this over, and look at these points right here. What's so special about them? Is it that they're on the x-axis? I mean, isn't that what we're looking for? That's really convenient. If they weren't on here, we need to use a t-chart and plug a few more points in. But I think we're in pretty good shape. We'll go ahead and graph this. Try to get the parabola the best we can. And there we go. And so we've graphed the parabola. That's going to be part of your assignment. Graph the parabola. We did. Identify, and now we got to solve it. So to solve, we're looking for where does it cross the x-axis. It crosses at 0 and it crosses at 6. Those are our solutions. Think about it. If you plug in 0, what's 0 squared? 0. Minus 0, what's 0 minus 0? 0. It works. If I plug in 6, what's 6 squared? 36. What's 6 times 6? 36. What's 36 minus 36? 0. It works. These are my 2 solutions. So you can always check your answers. That's the beauty of this. Okay? Let's go ahead and take a look at the second one here real quick. Okay? See how it goes. Okay. So the second one, very similar type of problem. I go ahead and my y-intercept, I like it at 16. Oh, I may not use that. That's too big. Okay, so I go ahead and I say, let's find the vertex. So the vertex is the opposite of b all over 2 times a. And so I get negative 4. Negative 8 divided by 2 is negative 4. Okay, so that's where we're at. You can go ahead and plug it bac in if you want, or 4ac minus b squared over 4a. And so here we get 16 minus 32 plus 16. And what you notice is we get 0. Awesome. Now that's so awesome because notice that what it is on the x-axis. And anything that falls in the x-axis is going to be a solution. So I technically already know a solution. And being that it's the vertex, I know it's either the bottom of a parabola or the top of a parabola. So this is going to be one of those one solution deals. Let's go ahead and find another point. Let's plug in negative 3 into a t-chart. If I plug in negative 3, what I get is I get 9 minus 24 plus 16. 9 minus 24 is negative 15, and then plus 16 is 1. Negative 3, 1. Negative 3 right here, and then 1. Okay, so if I fold it over, it'd be there. Let's see if it makes sense. It's a U shape. My A is positive. That means a smiley face, so that definitely makes sense. There's my parabola. That's not my answer. My answer is where does it touch the x-axis? It touches the x-axis at negative 4. That's my solution. If you plug negative 4 in, you end up getting 0. We've already done that, so we already know it works. Let's look at the very last one. Again, if you need to pause and go back and rewatch these, please do so. There's other videos online. Just look up solving quadratic equations by graphing, and that would help you as well if this isn't enough. Let's take a look at this very last one. Again, my constant, my y-int is 1. That's not too bad to use. I'll use it. My vertex is going to be the opposite of b, which is 0. So I'm going to get 0 over 6, which is just going to be 0. And so what I have is I have 0 comma something. If I plug in 0, I end up getting 1. Now remember what we need to do is we need to convert this to a function. I didn't do that up here, and I should have. I need to convert this equation to a function. This is what we're graphing. We're graphing this. That way when I plug it in, I'm solving for y. And so this is what we're solving for. So when we're done, this is what we're trying to accomplish, is what x makes this 0. But we need to graph the function to determine that. So if I plug it in, I get 0, 1. 0, 1. Now notice again, the vertex is the same thing as my y-intercept. So I need maybe another point. And so I get next, and I go ahead and I plug in a 1. Now this should be a U-shape because my A is positive. So notice if it's a U-shaped, I already know what my answers are. How many times is this U going to cross the x-axis? Here it is. How many times is this U going to cross this? It won't. It should be no real solution. If we plug in a 1, we end up getting 4. 1, 4, fold it over. There's our U. Okay. Notice there, here's our x-axis right here. That's our x. Where does it cross that? It doesn't. So our answer is no real solution, or no real root. Sometimes you hear them say, because remember, root is the same thing as solution, same thing as x-intercept, same thing as a zero. Okay? And that is solving quadratics by graphing. Go back here real quick. Okay? Again, make sure to locate. Graph the quadratic function. Convert the equation into a function. So just like we did right here. Convert it from an equation to a function. Then you can graph it. Once you graph it, you want to identify where does it cross the x-axis. Does it cross twice, there and there? Does it intersect once, or none at all? And so your answers are going to vary, and your x values are going to be the solutions. And you can always check your solutions by plugging them back in. They should equal 0.